Ohm's law graphs, grade 12 physics. The graph of conductors that obey Ohm's law is a straight line, and these conductors are known as ohmic conductors. And depending on what you have on the x and y axis, you'll have a different slope or a different gradient. So you can have voltage on the y-axis and current on the x-axis, or you can have current on the y-axis and voltage on the x-axis. Okay, so depending on what you have on the x and y-axis, you'll have a different slope. Okay, so we are going to see the slope that you can have. Let's start with this one. Okay, so use the above graph to rearrange the formula, this formula, in the form y is equal to mx plus c, because this is a straight line and this is the equation of a straight line. So remember this formula. Okay, the voltage is equal to the current times the resistance. Okay, please check the link in the video description. So we go back to our problem. You have to use the above graph, okay, to rearrange this formula in the form y is equal to mx plus c. Okay, so y is the subject of the formula. Using this graph, voltage will be the subject of the formula because voltage is on the y-axis. Okay, so you are going to have voltage as your y. Okay, so you can see you have voltage as the subject of the formula. Okay, so you are going to have voltage as the subject of the formula because voltage is on the y-axis. This is equal to current times resistance. Okay, current times resistance. I can rearrange this like this so that you can see clearly. So you can see y is equal to v. Okay, on the y-axis you have v. M is equal to r. X is equal to I, the current. You can see the current on the x-axis, and C is equal to 0. Okay, C is equal to 0. So you can see the slope is equal to R. Okay, so the slope or the gradient is equal to R. You can see. Okay, now when you have current on the y-axis and voltage on the x-axis, what will be the slope? Okay, you are going to use the above graph to rearrange the formula. Okay, still the same formula. You have to remember this formula because you are going to use it in many problems. Okay, you are going to rearrange this formula using this graph. Okay, you have to rearrange this formula in the form y is equal to mx plus c because this is a straight line. This is why you have to rearrange in this form. This is the equation of a straight line. Okay, now can you see current is the subject of the formula because you have current on the y-axis. You have to make current the subject of the formula. So what you can do is to divide by resistance on both sides so that you can be left with current alone. You can divide by resistance on both sides. Okay, what you do on the right, you also do it on the left. Now, you are going to cancel this and this. Now you have current is equal to V over R. Okay? Can you see? You make current the subject of the formula, and you can rearrange this formula so that you can see clearly what is your Y, what is your M, what is your X. Okay, current is equal to, there is an invisible 1, so you have 1 over R times V. Okay, we carry on. Now you can see current is the subject of the formula because current is on the y-axis. So your y is current, your gradient is 1 over R, okay, 1 over R, and X is V, the voltage. Can you see voltage on the x-axis? Okay, so whatever you have on the y-axis, you are going to make it the subject of the formula by rearranging this formula. Okay, you rearrange this formula in such a way that you can make what you have on the y-axis the subject of the formula. Okay, now in this case you have the slope is equal to 1 over R. Okay, you can also get the slope using this method. Let me show you. Remember, the slope is equal to change in the y over the change in the x. Okay, using this graph, your change in the y, okay, change in the y. So change in the voltage over change in the x, okay, change in the current. Okay, using this graph, can you see you have V over I. What is V over I? Okay, V over I. When you divide by I on both sides, this and this will cancel. You are going to have the resistance is equal to V over I. Okay, V over I is equal to resistance. Okay, can you see which is the slope? Okay, the slope is equal to the resistance. Okay, using this graph, the slope, okay, the slope is equal to change in the y over the change in the x. Okay, in the y, you have change in the current over change in the x. You have change in the voltage. Can you see? You have I over V, which is the inverse of this. Here you have V over I is equal to the resistance. Now, here you have the inverse, okay, current over V. So, this will be the inverse, which is 1 over resistance, which is this, what you have there. Okay, so you can use this method to find your slope, or you can use this method by using the equation of a straight line, trying to rearrange this formula. Okay, use the equation of a straight line. Because you have a straight line, you are going to rearrange this formula. Okay, you have to remember this formula. Okay, so we can move on. Okay, now we are going to compare slopes of Ohm's law graphs. We are going to use this question and this question, okay, to compare slopes of Ohm's law graphs. Okay, let's start with this question. Arrange the two lines, okay? Arrange the two lines, one from largest to smallest slope, okay? Number two, from largest to smallest resistance, okay? Solution number one, from largest to smallest slope. By experience, I know the slope whenever I have lines from the same point, okay? Whenever I have lines from the same point, I know the slope is increasing in this direction, okay? Whenever I have lines from the same point, I know the slope is increasing in this direction. The steeper the line, the larger the slope. So, you know the formula for finding the slope is equal to the change in the y, okay, over the change in the x, okay. To find the slope of a line, you have the change in the y over the change in the x. So if we have to compare the slope, from experience, I know the slope of this line is greater than the slope of this line, because whenever I have lines from the same point, the slope is increasing in this direction. So the slope of this line is greater than the slope of this line. But I'm going to prove that for you. Okay, let me show you how we can prove. We can maintain x or y. Okay, let's maintain x. So if we maintain change in the x for both lines, let's say from that point maybe to this point. Okay, so let me show you. Okay, a straight line. So we maintain the change in the x. Okay, now we are going to compare the numerator change in the y. Can you see for line number one, the change in the y is from that point to that point, okay, for line number one. And for line number two, the change in the y is from that point to that point, okay, for line number two. Can you see line number two will have a larger change in the y. The change in the x is the same for both lines, okay. We maintained the same change in the x. So the larger the change in the y, the larger the slope, okay. As I said, the slope is increasing in this direction, okay. So the slope of this line is greater than the slope of this line, okay, from largest to smallest. Okay, now number 2, let me erase everything. Now number 2, arrange from largest to smallest resistance. Okay, you have to remember this formula. Remember this formula. I've got a video in which I explain how to remember this formula. Please check the link in the video description. So we have to compare resistance. Okay, what is resistance? The resistance is equal to V over I. Now we have to compare the resistance. Which line has got a larger resistance? We can maintain the denominator, okay, the current. We can maintain the current and compare the voltage. Do you understand? The larger the voltage, the larger the resistance, okay? So we can maintain our denominator, okay, our current. Let's say from that point to this point, okay, we are going to maintain the same current for both lines, okay, the same current, okay, the same change in the current, okay. Now we are going to compare the voltage for both lines, okay. The larger the voltage, the larger the resistance. Can you see? Line number 1, the red line, the voltage is smaller as compared to the voltage for line number 2. The voltage is larger. So this is going to have a larger resistance as compared to this. Okay, the larger the voltage, the larger the resistance. Okay, the larger the voltage, the larger the resistance. This has got a smaller resistance, you can see, because of a smaller voltage. Okay, so this resistance is greater than this resistance. Okay, now let's compare the 3 lines. Okay, solution number 1. Again, when I have the lines from the same point, I know from experience the slope is increasing in this direction. Okay, I have proven that from this question. Okay, when I have lines from the same point, I know the slope is increasing in this direction. Okay, the steeper the line, the larger the slope. Okay, the steeper the line, the larger the slope. Okay, so the slope of line number 3 is greater than the slope of line number 2, greater than the slope of line number 1. Okay, from largest to smallest slope. Okay, now number 2, we have to use this formula again. We are going to compare the resistance. Okay, so this is the formula. We are going to maintain the current. Okay, we maintain the current and we compare the voltage. Okay, the larger the voltage, the larger the resistance. Okay, let's maintain the current. We can start from that point to that point. Okay, okay, we have all 3 lines. So we maintain the change in the current. Okay, now we are going to compare the voltage. The larger the voltage, the larger the resistance. Can you see number 1 has got a larger voltage, followed by number 2, and then number 3. Okay, so you're going to have this. Number 1 has got a larger resistance. Okay, the greater the voltage, the greater the resistance. Okay, this is what you're going to have. Okay, I hope you understand. Okay, we are done.